This is the Resilmesh Threat Hunting and Forensics version 2 module. The focus of our functional component is a threat hunting large language model conversational agent. Threat hunting is the practice of discovering active threats in a software environment. Large language models are trending as emerging assistants for navigating said environment to discover these threats. This threat hunting framework is primarily based on the C3 threat hunting methodology depicted here in the diagram. This C3 process is composed of 3 phases: the construct phase where threat hunts are initialized, the conduct phase where data is collected and evaluated, and the conclude phase where the technical findings of the threat hunt are reported and documented. Note the 2 conduct stage intents highlighted in red. The primary step of our conversational agent is to identify a set of functional threat hunting intents from the diagram which can be implemented, and the LLM can provide support in identifying these intents. Defining a fully automated agentic C3 process is beyond the scope, and many of these C3 intents are of varying granularity. For our THF component, we converged on these consolidated conduct stage intents highlighted in this table of intents. These optimal threat hunting intents correspond to the 2 highlighted conduct intents from our earlier diagram and are implemented in our LLM-based web application. So, this is the Resilmesh C3 Threat Hunting Assistant for the THF module. This module is a React-based threat hunting web application and is powered by a large language model, LLM, conversational agent. The LLM used is Claude Sonnet 4. The actual web application is developed using the open-source library called LangChain, uses a fast API server, and is integrated with a Wazoo OpenSearch backend. Here, we observe the Streamlit graphic user interface, where an end user interacts with an LLM chatbot. This application enables an end user to perform various threat hunting-focused operations against the Wazoo OpenSearch database. The end user will submit their natural language threat hunting query in the chatbot as shown here. In response, the LLM generates and displays contextualized threat intelligence to said end user. The LangChain application supports a wide variety of dynamic threat hunting focused functionality targeting network entities including agents, processes, security events, and network flows in the Wazoo data. Different threat hunting functionalities supported by this LangChain application include 1. Investigating a network entity, 2. Analyzing security alerts, and detecting anomalous behavior. Let's start threat hunting with our LLM agent. We'll enter a security question in the chatbot. Okay, so here is the threat hunting query I will submit to the chatbot. Once this query is submitted, the LLM agent infers the threat hunting intent, i.e. investigating a network entity, and other input parameters including the target entity, the agent, and the temporal filter, the past 10 hours. Based on these parameters, the LLM agent executes the appropriate LangChain functionality which executes dynamically constructed OpenSearch queries to perform the actual data retrieval. Let's submit this query and analyze the resulting LLM-generated threat intelligence. So, here in the front end, beneath the LLM assistant, we observe that the LLM agent's generated threat intelligence responds to our submitted query. In the application workflow, once the appropriate LangChain functionality returns the relevant Wazoo data, the application extracts inherent cybersecurity insights. The LLM agent, guided by defined LLM prompts, then generates this dynamic comprehensive threat intelligence based on this process data. As we observe here in our Streamlit frontend, the returned threat intelligence for our alert breakdown query is composed of an alert summary of our query's targeted agent displaying the following metrics: the total number of alerts being 318 alerts, the host's alert frequency and the highest recorded alert severity being critical, level 15. We also observe an alert severity distribution with the percentile for critical events make up approximately 10% of the alert breakdown. Further down, we observe the 5 most frequent security rule groups, and indicated by the warning sign, we see that the 26 critical, level 15, events from earlier belong to this security rule. This analysis also identifies the process clean manager.exe dropping DLLs in temp folder as a critical finding of these alerts. Further on, we observe additional security insights such as a timeline of these events and other notable activities. Finally, the LLM's threat intelligence response concludes with actionable recommendations to 1. immediately investigate the alerts describing the process cleanmanager.exe dropping DLLs in temp folder, and 2. Review the net.exe management instances. Now, I want to immediately follow up and investigate the cleanmanager.exe process from our alert breakdown from this time frame. So we enter this follow-up query to investigate this entity in the chatbot. Now, in the chatbot, the LLM agent returns this investigative summary based on the cleanmanager.exe security event. We immediately observe the key security insights of the cleanmanager.exe process, including the following metrics: the timestamp of the alert originated from the host, as well as the process ID of the event. Next, we observe recorded suspicious activity related to this alert, noting the DLL file dropping pattern, and we observe the 26 occurrences mentioned in the previous LLM response. Further down, the LLM response notes the MITRE attack mapping, identifying the attack technique and tactic and the technique description. The LLM-generated response also includes a security assessment highlighting high-risk indicators. Finally, we observe actionable recommendations for additional follow-up threat hunting measures, including the suggested measure to isolate the agent U209 PC BLEE. So, let's perform further analysis this cleanmanager.exe entity. We'll investigate what other entities the process connects to, has a relationships within this time frame. So, this latest LLM-generated response returned is the relationship mapping analysis for this high-risk cleanmanager.exe process. The other entities the process has a relationship within our time frame are displayed as follows. We see the hosts where the process was executed, including our investigated host. We see listed connections to other hosts it was executed on, the connected files the process interacted with, specifically the DLL files that were dropped into temporary suspicious-looking directories on targeted hosts which triggered an alert rule.